All right, everybody. So today I'll get straight into the topic for the video. Okay. Um, so this one is about some rules for calculating limits. Now, so far I've made videos to show you the basic idea of a limit, and that included how to calculate a limit by a table, and then I made one about how to calculate limits by graphs, and then now some rules. Okay, and so there are different ways that you can calculate limits, and it depend on the problem and the information that you're given. If you're unsure, you can always ask. Now, so let me just go straight away and tell you about the rules. Um, so this first rule says that the limit as x approaches a for a function f of x that is a polynomial, and I'll tell you a little bit about what a polynomial is in just a second. To find that limit, you could just plug in the number. Okay, that's what that says. If I was going to state it in simpler terms, that the limit as x approaches a for some function that's a polynomial f of x is f of a, which is the function value or result when you plug in a. Okay, so let's see an example. Okay, so this one says, what's the limit as x approaches 3, 4? Now that's a polynomial. A polynomial is a function that is such that all the x's have positive whole number powers. Like all the powers for the x are 1, 2, 3, 4, 5, 6, and so on. Okay, so that's a polynomial. So the limit as x approaches 3 for 2x to the 5th power minus x to the 4th minus 5. All right, now that rule said that in this case, I could make a table, see, I could do that. I mean, I did show you how in earlier videos, but the rule says we can just plug that 3 in, and that would be a lot easier. So I did that. 2 times 3 to the 5th power minus 3 to the 4th power minus 5, and then that was 400. So that's the limit, okay? If I did make a table, here's what would happen. I would see numbers like 400.01 or something like that. Maybe 399.99. Who knows? It probably looks something like that. I don't know exactly because I didn't make the table, but if 400 is the answer, then that's what I would expect to happen if I did make a table. All right. Okay, now let's look at another rule. What is the limit as x approaches a for the nth root of f of x? Okay. Now, I mean, this rule says that, again, you can just plug in given that this has some known answer. Or so say it's known or it can be answered. Then you just plug in. All right, now say that, again, still a matter of just plugging in a case like this. How do you think you would do this one? See, what's the limit as x approaches 3 of the square root of 2x to the 5th power minus x to the 4th minus 5? Okay. Well, okay. So that rule did say I could just plug in my result, right? Like, so do we know, like what's this right here? Do we know that part of it? Yeah, so we did it up here. That's 400, okay? So what that rule says is that this will be my answer, square root of 400, because I know that part in there. I know its limit is 400. No matter how I found it out, I know it. And so then my result, the limit, is the square root of 400, which happens to be 20, all right? Okay, so we can plug in a case like that. Now, there is some fine print to this rule. If plugging in gave you the square root of negative 4, then, well, that's not calculated as a real number, so we would do it then, but I don't think we're going to run into that. So I'm not going to worry too much about the fine print. Okay, now these last 3 rules tell us that, if, say, I know these individual limits, say I know what happens to f of x as x approaches a by itself, like if it was its own problem, and I know what happens to some other, so what's g of x? Some other function, some other formula, some other problem that has an answer. So say I knew that, then it's just saying, again, all this says is that I could answer such a question if it was one formula plus or minus another by plugging in the number x approaches, okay? So without overanalyzing it, that's what I'll say. What about the addition and subtraction? Well, it's the answer to this one plus or minus the answer to that one. That's what it says. The same thing is true for division and multiplication. So you can plug in for your limits so far as these have answers, or in that you know them somehow. It doesn't matter if you add, subtract, multiply, or divide, is what those last three rules say. Okay? Now, on this one with division, there's some fine print that we will run into, and that's that, well, so for this situation where you have one function or formula divided by another, then you can plug in individually and divide your answers, okay? But only if that bottom answer, that bottom number doesn't turn out to be 0. That's something we will run into, and I would like to show you a little bit about that with some examples. Okay, so let's see. Here's one where it says evaluate the limit, and it has division in it. And what this was telling me was that I can plug in into that top function and plug in into that bottom one, as long as I don't get 0, in the under the bar. I can't divide by 0. So, well, let's try that. So I get 3 squared plus 3 times 3, take away 18. So that's plugging in the top. And then I'll get 3 squared minus 1. That's plugging in the bottom. Okay, so let's work that out then. So that's 9 plus 9 minus 18. Okay. And this is 9 minus 1. Now on top, that's going to be 0 over 8. Okay, is that okay? Let's see. I can't divide by 0. I can divide 0 by some other number. 0 divided by 8 is 0. Okay, so there's our limit. If the x is close to 3, the y will be close to 0. Oh, I changed variables. I forgot to mention that. Does every function have x as the input variable and y as the output variable? No, the variables can be whatever makes sense. Maybe we'll use t for time. In economics, they use Q for the quantity that's bought or sold. They use P for price. So we'll see lots of different variables, and I used N just because I wanted to mix it up a little bit. Okay, so it's okay to divide 0 by something else. That's fine. If you got your calculator and you said, what's 0 divided by 8? Enter, it would tell you 0. Okay, so no controversy here. That's our answer. Okay, we can't divide by 0 though. That's the problem. So let's do this other one. Here's another example. It says the limit as n approaches 3, n squared plus 3n minus 18 over n squared minus 9. So let's try the plug-in approach. Okay. So let's see. If I plug in 3, I'll get 3 squared plus 3 times 3 minus 18. And I know I already worked that out, but I'm going to pretend that I haven't. And then 3 squared minus 9. Okay, so that's what plugging in gives me. Let's see if that's okay. If this gives me something that can be calculated, that will be my answer. If it gives me some division by 0, then it won't, and I might have to attempt something else. Okay? All right, so let's see. I'm going to get 9 plus 9 minus 18. And I'm going to get 9 minus 9. And I get 0 on top, and that's okay, but I also get 0 on the bottom. Okay? All right, so that's what's no good about this. That's what's about it that doesn't give me an answer. Okay, so that doesn't mean that there isn't an answer to this one, though. If you make a table, and if you put the n's close to 3, you will find that gives you the result of this formula close to some other number. It's just plugging the n being 3n doesn't work. It doesn't reveal the answer. So let's talk about what you do in that case. All right, so let's see. What we do in that case is we take this problem, this expression that we're given, and we reduce it or simplify it, whatever your preferred terminology is. Okay, so here's what I mean. So let's see. Is there some way to take this and reduce it to something that is simpler than it appears to be at the moment? And there is. If now, to get in this class, you would have needed to take some algebra, and one thing that you learn in algebra is how to reduce or simplify these, they're called rational functions. Okay, so the way that I do that is I factor. Okay, I'll do, let's see, how do you factor n squared plus 3 and minus 18? That will be n plus 6 and n minus 3. Okay, and I can always check that. I can multiply this back out. N squared minus 3n plus 6n, so that's 3n, and minus 18. Okay, so that's the right way to factor the top. And then the bottom, factor this as n plus 3, n minus 3. Now, there are lots of things that could come up in our class. One of them is reviewing. Now, I will take this stance when I make these videos that I'll assume you know stuff from algebra that you would have learned when you took algebra. If that's not true, if you've forgotten it, if it's just been a long time, that's okay. I don't mind making review videos, and I've already made a lot of algebra review videos for my algebra classes. So if you need to see something about how you factor, because that's all I've done there is factor everything, then I can post those videos and you can look at them and it'll give you a chance to review. Now, I don't know if that's the case or not, so you'll have to tell me if you need to review. Now, what I noticed when I factored this is that some things cancel. N minus 3 over n minus 3. Why do they cancel? Well, because any number divided by itself is 1, and so that's essentially 1, and we don't bother writing the 1. Okay, so I factored it, and now some of it cancels, and it does turn out to be simpler than it originally appeared. What's left over after I cancel is n plus 6 over n plus 3. Okay, so I reduced it. That was the goal of the second step. Plugging it in didn't work because I can't divide by 0. So in that case, I'll reduce it and simplify it, and I'll reevaluate the limit. Okay, so now we should have better success if we reapply this on the simplified form of our problem. And how we would do that is by plugging in our number. So if I plug in 3, because aren't we allowed to plug in as long as we don't get division by 0? Yeah, okay, so let's see. If I plug in 3, I'll get 3 plus 6 over 3 plus 3. Okay, so that's going to be 9 over 6, and I can reduce that to 3 over 2. So you can answer 3 over 2 or 1.5. All right. Now we can't get that answer by plugging in 3 for n straight away when we started, but you can confirm this answer if you wanted to. If you wanted to practice and test your understanding, make sure everything is lining up the right way, you can confirm this by a table. Okay, I'll leave that up to you, but I think if you're learning it, it's a good thing to try to go as deep as you can. Okay, so you might try this. What would confirm my answer is 1.5. It says the limit as n goes to 3. I might put in 2.99, 2.999, 3.001, 3.01. You get the idea. I do something like that. And all of these numbers over here are going to be about 1.5. That's what you're going to find out. Okay, that table would confirm this. Now, so there are different ways that you can do it. I'll ask you to, I'll say follow the instructions on the assignment. Okay, so the instructions on the assignment might say to solve this problem analytically. And the instructions, if a table is warranted, might say solve the limit by calculator or something like that. Okay, so follow the instructions that are given with the assignment. If you're unsure, then you can always ask. Even if this video didn't clarify how to do a similar problem in the assignment, you can ask about that too. But this is how I'll start the conversation. I'll post the video, and I'm anxious if you have any questions to forward my way.